off kinect sensor. So I was working with the kinect for the Building Trust project, which Sarah is running, and the kinect would be used to detect certain behaviors people are making during the study, and so that we can figure out like if they're feeling distrustful or things like that. So the kinect has two cameras. It has a color camera and an infrared camera, and it also has a microphone array. So we've used all of those to collect the raw data from the kinect. So the data from the kinect has to be sent to a place where it can be used with ROS messages. So it starts out in the kinect and is sent directly to a Windows computer. The Windows computer then parses into a JSON string, which is sent to a Linux computer. And on that computer, we have 3 different files. One's listening for the audio information, one's listening for body information, and the other one's listening for face information. And those files take the JSON strings and format them into ROS messages, which are then published on the topic. So then from there, we can actually perform the calculations with the data, and we do that in a separate program. We calculate things like leaning forward and backward, and if their arms are crossed, things like that. And then that calculated information is then published onto a new topic. So now to go into a little more detail about the data itself. As I mentioned before, we're looking at body behaviors, so we can determine if someone's feeling distrustful, and that could be indicated by them leaning backward or crossing their arms or touching their face. But before we do all of that, we have to find a way to keep track of all of the data as it relates to each individual person. So at the beginning, we assign each person kind of like a seat, and that's based on the position of their head, which within the first 10 messages sent. So yeah, and that's good because it's a relatively organized way to keep track of all of the data. But it does mean that everyone has to be sitting in their position once the program starts. The kinect assigns these tracking IDs to each body in the frame, and we use those tracking IDs to match up the audio data and the face data with the bodies. But sometimes the kinect will lose track of a body, or somebody can walk out of the frame, and then once they re-enter, we want to make sure that the data that we collected before is preserved and matched up with the current person. So we check the last known position of everyone in our list, and we check the seat kind of as a last resort. So if somebody walks in and returns to their seat, we can match them up with the information from whoever was sitting in that seat before. So once we have a way to organize all of the data, we can look at what it sends us. It sends joint position and orientation information for about 20 different joints, but we're really looking at only a few of them, which is the spine, the hands, arms, and the back. So with that information, we calculate 4 main behaviors. The first, as I talked about, was leaning forward and backward, and that's just based on the orientation of the spine. We also calculate if their arms are crossed, and that's by measuring the distance of the right hand from the left elbow and the left hand from the right elbow. We measure the distance between the hands to determine if their hands are touching and if either one of their hands is touching the face. So as well as body information, we look at face detection, and the main reason we're looking at that is to determine if one person is looking at another person. To do this, we have to look at kind of 2 different angles. The first is from the person's orientation, side to side, which is a Y orientation. And we also have to look at the pitch, or up and down movement. Yeah, so in this diagram, if we have here, this is the kinect. If person A is looking directly at the kinect, that's an angle of 0. So we want to calculate this angle that they should be looking at to see person B. And we also have to do the same thing here. Again, person A looking straight at the kinect is 0. And this angle here is what they need to be looking at person B. Yeah, so the kinect is pretty accurate when it comes to face orientation and position, but the only problem is if a person turns past about 90 degrees on either side, or they look up or down like around 40 degrees, it loses track of their face, which is sometimes a slight problem with how the people are set up in the room. The last thing we looked at was audio data. We wanted to measure the volume, and the kinect sends this kind of raw audio stream that we can calculate an approximation of volume from by using a root mean square of all of that. We also look at the total time someone is talking, and we do that by every time the kinect receives audio data, it sends it in a 16 millisecond interval. So every time we receive data, we increment it by 16 milliseconds. And then we also just keep track of, is a person talking or not, and that's mainly so that once we have the robot running, like, it doesn't interrupt people when they're talking. Yeah, so there were still a few issues with the project. The first thing is that when we run the program for like 15 to 20 minutes or more, sometimes the connection will randomly drop out. We're not really sure why, so that's definitely something we need to look into. The other thing, as I mentioned before, the kinect accuracy in terms of faces and losing track of people's faces. The other thing is that when people are sitting, it's not very accurate in terms of their hand positions. So that causes the data on if their hands are touching or arms crossed or any of that to be much less accurate. A possible solution could be using multiple kinect sensors to get a wider frame of view for the face data and maybe to cross-check the information. And the other thing we looked into was possibly doing speech to text. Unfortunately, the Windows computer we were using wasn't able to recognize the speech from the kinect, and the speech recognition software we were trying to use was not compatible with our computer, but that's something to look into in the future. Yeah, so I spent most of my time with the kinect sensor, but in the past week or so, I've been working on controlling the Now robot and looking at game events for the game that will be used in the study. So yeah, I basically have a script, and it does three main things. The first is that it subscribes to the information topic that I mentioned before. That's where the kinect data on like arms crossed and talking and all of that is published. And from that, it gets information just mainly about if people are talking and about positions of people, because in the future we might want to have the robot look at someone or not look at someone. It also subscribes to a game topic where it gets events from the game, like has the game finished, is it successful, if it wasn't, like who caused it, and things like that. And then based on the information from those two places, the Now robot responds by talking and making gestures. So yeah, that's pretty much it.
Isabelle, what technologies did you learn for the first time?
Well, I learned about using ROS, which I hadn't done at all. Yeah, that was really cool. I enjoyed working with the Now robot. I just learned a lot of programming in general, too.
Isabelle, you're going to be a rising senior this year, is that right?
Yes.
What's next for you?
I
I only ask the hard questions. Everyone else knows that, and you guys aren't supposed to that yet. Okay, let's talk about that.